Okay, so hello everyone. I'm going to talk about what we did at Criteo to optimize our performance from our clients. So first, a bit of a context. So who we are at Criteo, because we need to know why we needed to do that. So we are a French startup. We started in 2005, and so we are 10 years old. And we try to keep the spirit of the startup. We are doing a lot of machine learning because we are an ad tech industry business in the ad tech business, and all we try to do is predict the behavior of people and how they will react when we display something, to be able to optimize when to display and when not to display. So we are 230 in the R&D, mostly in Paris. We also have a team in Palo Alto, small team. And we are 1,500 worldwide. So we have a lot of office all around the world, but mainly in Paris. So what is our business exactly? We are doing personalized ads. And every time we need to display an ad, it's a totally personalized ad generated in real time. And we do that a lot of time, every second. So the number of are here. We did almost we did 741 billion ads in 2K14. So we expect that to double in the next year. And we have almost 1 billion unique visitors as of today. I think we reached the billion. And yeah, we are trying to optimize our banner, not only to gain money for us, but also to gain money for our clients, because we are trying to optimize the money they drop to us in front of the money they gain from us. So this is all our business, and this is why we need a lot of data everywhere. So I'm working in the SRE team, Site Reliability Engineering team in Criteo. We are around 50 developers, developer or ops, and mostly DevOps. And what we are doing is, the first one is software engineering, software infrastructure, sorry. And so we have a team dedicated for the system. So they are working at the OS level and hardware level. We have a team dedicated to automating everything. We have a team for the big data infrastructure, which is more the Hadoop things, the Storm, Kafka, HBase, etc. And a team, so from which I am the lead, dedicated for the NoSQL infrastructure. So we are using Memcached, Couchbase, Graphite, Elasticsearch, MongoDB, Cassandra, Redis. So, okay, I'm reading my slide. We also have the escalation team in the SRE. So escalation team is where all the problem drops when something happens, and they try to dispatch it in the whole R&D. And we also have a team dedicated to have a predictive monitoring, which means they try to foresee the issue before you can even see them with your eyes on the usual graph monitoring. And also we have the team dedicated to provide tools for all the developers. So the automatic testing of code, continuous integration, yeah. About our hardware infrastructure, so we are running 6 data centers. So we are not in the cloud. We are not using a cloud service. We have our own data center. We have more than 10,000 servers, so bare metal servers, and it's roughly half Windows and Linux. Because in fact, all web servers are running on Windows, and it's more about the databases and all the Hadoop things which are running on Linux. We also have our own dedicated network. We are renting black fibers to go from one data center to one another. They are all around the world, and our network does a big ring all around the world. with really big links. And we also have one of the biggest Hadoop cluster in Europe. So I mean one of the biggest. It's just because we don't have the real number for the state clusters, which does not give us the number like for the I don't know. So we have more than 1,000 servers just for the Hadoop cluster and 35.7 petabytes of storage on it. So now, why did we started to use Couchbase? At the beginning, we started to store all our user data in the cookies on the browser, web browser, and also all what we call the inventory databases were just in the Microsoft SQL servers, and that's it. It really worked well. At some point, we needed to do more because we added some issues. So the first thing was to have a cache outside of our application, web application, because the memory inside our web application was not sufficient, and so we had trouble with it. So we needed to share the cache using Memcached. And also, we had to handle the server-to-server call because at some point we wanted to connect using the RTB. I will talk a bit later of that. And so that's why we started using Memcached. At the beginning, it was just one big instances with one big server, and that's it. And so at some point, so real-time bidding again. So real-time bidding is when someone is going on a web page and there is what we call zones where we have to display a banner. So for instance, the Google server which handles the zones is going to contact many third-party servers and to ask them, how are you willing to pay for displaying a banner here? And so we have 100 milliseconds to bid, to answer with the banner and this is the price I want to pay for that. And so the first one we pay the price the second bidded. And so we have 100 milliseconds, and when you remove the latency of the network, then it just remains 50 milliseconds to build the banner, predict how much the display will return. So, and this is where we are going to have trouble using cookies because we don't have anymore the user data which were stored in the cookie browser because we don't have the browser, we don't have an HTTP request going on our own data center. So we needed to have something shared, stored locally in our data center. Also, an additional challenge is that we have several data centers, and while the browser will have the same cookies on every data center, here we have several data centers with local databases. In fact, at the beginning it was Memcached. And so we had to, every time we update something, to propagate the update everywhere. So since it was Memcached, we just propagated using the clients. In fact, we spawned several clients connecting to the other data center, and that's it. We propagated the changes on our Memcached. And so also we started to have a lot of instances because one big Memcached wasn't enough at some point. We needed more because to handle more memory and to handle more client requests. And so we needed to add more and more nodes. And also we wanted to be able not to lose everything every time a server is crashing or everything. So we used Couchbase because it allowed us to persist what was in the Couchbase. And also it helps us to deploy more and more Memcached or instances. So two good points for us. So as of today, where do we are? We have 550 Couchbase nodes on our production, so split it in 6 data centers. We have 4 clusters per data center, so 24 clusters total. And we have 107 terabytes of memory and the same as SSD because everything which is on SSD is also in memory for performance issue. And we have, on average, 10 million hits per second on our Couchbase. And it's an average, so since the data center are getting localized traffic, it's very unbalanced, and we can handle on one single server up to 2 million hits per second on a peak when, for instance, we want to restart all the application of a data center and they need all to refill their cache, their local cache. So, new issues. So, as of today, yeah. On the peaks, it's mostly gets because it's when we restart the application and they need to refill their cache, their local cache. But there's a bit of sets also because if the information is tailed in cache or just not there, then it have to query the SQL server to start and repopulate the cache. But it's like, I would say, 1 for 20. One set for 20, yeah. The biggest cluster is like, I would say 38 nodes. So yeah, we have today more than 2.5 thousand clients. And when I say clients, it's web servers, big web servers. It's IIS.NET servers. With 2 worker process per instance, so you can double the number because here it's the number of servers. And also we have slow links between data center we need to synchronize. So for instance, at the beginning it was a synchronization between the New York and Sunnyvale data center, and so the speed of light inside the fiber make us impossible to do less than 70 millisecond ping even with the best quality fiber. So slow link plus a lot of clients implies many issues. And also the clients we add, so provided by Couchbase, is totally synchronous, so it does blocking calls. So every time you want to give something from Couchbase, you have to wait on your threads until the response comes back. And so you had to spawn more and more threads to be able to handle that. Just to understand, today to generate one single banner, we have to do roughly 50 calls to Couchbase just to generate one banner. So blocking calls are really a mess for us. And so we had to spawn more and more and more TCP sockets. And we reached the 9K limitation on Couchbase of connection, TCP connection on a Couchbase instance. And also our clients had huge issue of number of threads we had to spawn. At some point I put it like 100 threads just to do the sets over the America, the continent. And it wasn't sufficient enough. So we started to just enqueue jobs in our thread pool, and at the peak time, then it was not sufficient enough, and so the jobs were stacking and stacking and stacking, and we had huge trouble with out of memory exception at peak hours and all restarting. So it was really a mess. So we started to find solutions about that. At first, we used Moxie. So Moxie is kind of a proxy for Memcached. It also works with Couchbase. So Couchbase is working on it. So at the first time, it was unstable. So the problem has been fixed. It's still a bit unstable, but really less than when we started to use it. It also used a lot of CPU load. So the Moxie were on the same node as the Couchbase, just because we wanted to limit the number of connections between the client and the node. So by putting the Moxie on the same node, so they can factorize connections. And so the Moxie will get a lot of remote connections and a few connections to the Memcached process, which is started by Couchbase. So, and also it uses a lot of CPU because Moxie is doing mainly hash computation to know where in the cluster it has to put a key. So usually the client is doing that, but sadly here, the client is no more doing that. It's up to Moxie to know where the key have to go. And so when we have 3,000, more than 3,000 clients, and now you go to 500 processes, nodes, to compute the same hash, then you have trouble with CPU computation. Just for that. And also the boundaries seen from the Couchbase node was multiplied by 3. Multiplied by 3 because from the point of view of the Couchbase node, because the requests have to enter into the Moxie, get out of the Moxie, going to another node most of the time to hit the Memcached, going out of the Memcached, going back to the Moxie, and back to the client. So instead of having 1 in and 1 out, you have 3 in and 3 out. It triples the bandwidth. So it was good to go a bit farther, but it was not yet enough. And so at some point, I decided to prototype something because I was almost sure I was able to do better than that. So yeah, here I just started to read the binary protocol, the Couchbase Memcached binary protocol, which is also used for Couchbase, and I started to implement it and see what happens. So at the first time, so we are using .NET. So I read the MSDN and look at how to connect to my cluster. And so I started and I seen several methods. So the first one is the synchronous one. I wanted asynchronous because, as I said, we have a lot of query to send just to respond to one single HTTP request. So I want my interface to be asynchronous. So having a send made me, forced me to spawn a new thread pool just to execute my query, not in a blocking way. And so I have to span thread. It's not really fun spawning threads per socket when you have still a lot of sockets. And also we have to buffer the query. And so you had a tiny lag. And this lag is something we really want to avoid when we have a lot of query to answer. So still we have 50 milliseconds to respond to a query. So don't add lags. So it was not a good idea, but it really worked well in terms of bandwidth when you just send the raw protocol. Second time, I started to use a second API on the socket in .NET, which is begin send and send. So it's cool. It's asynchronous. You just get it a callback, and it just call you in the callback. So no more user-handled threads. It's just threads handled by the OS. And it's cool. It's asynchronous, but it adds a huge CPU overhead. So it was not good at all. And so I started to try the second asynchronous API in .NET, which is really more, it's more new, I would say. And so I had to try it. And you just give a simple argument in which you give it the byte buffer you want to send, the callback, the size of the data you want to send, etc. And everything is stored in this argument. And in the first time, okay, it was asynchronous, and like the first one, it added a huge overhead. So I tried to look at how I could limit this overhead, and in fact, the only solution was to reuse this argument and just change the byte buffer inside. And then at this point, I had no more overhead. It was really almost free in CPU to use that. So cool. I think I have my API to send data. So in the end, this is how my API should look when I want to do a GET. So I have my client, and I just give it a callback with arguments, the status, which is most of the time no error, or you have to handle it. And you have a byte buffer, because I just handle byte buffer. And so the only thing you have to take care of is when you do asynchronous things, you have to check the fail synchronously and in the callback, because things can fail in these 2 points. So this is it. So I speak about asynchronous, but why do we want to do asynchronous things? The first one is because we want to limit the number of context switch from the OS, because at some point the OS just spend all its kernel time to switch from one thread to one another. So also you have less threads, so it's easier to debug. And the last but not the least, it makes you able to pipeline your protocol. And the binary protocol in Couchbase is, and Memcached then in Couchbase, is okay to be pipelined. It's made for that. So okay, let's go. Let's try it. So what I mean by pipeline. So in a sequential model, what happens in every Memcached or Couchbase client is that you have your web server, you want to send a request to Couchbase. At some point, another request has to be sent, but it has to wait for the previous request to be received before you can even start to send the next one. So this is an issue, and I want to pipeline, so this is how it works. You just send a lot of requests, your server sends a lot of response in the same socket, in one single socket, and so if your web server has a new request to send, no problem, no worries, you can do that. At some point, you are limited by the size of the TCP Windows, but I will speak about later. Also, I wanted to add the socket pooling. What is the socket pooling? It's just when you want to connect from one client to one server, then you put several sockets, and then at some point, if you want to send a request, because while you are starting to send a request, then you have to wait for the API tells you that, okay, it has been sent, then you cannot send something else. So if you have a lot of requests to send, at some point, it will also decrease your performance and you will have a lock. So if you have several sockets, then you are able to never wait for any sockets to be free. And so you can even increase your performance and decrease the latencies. And then also the TCP Windows. So TCP Windows is the size of in-flight data that can be, that the TCP allow between two peers. And so if you increase your TCP window, what does it mean? It means that if you have any errors at some point, it will need to resend all the data that were in flight from the beginning, from the last acknowledgement. And so if you increase the size of the TCP window, you can acknowledge the data less frequently, and so you can fill more and more queries in a single TCP socket, and it's even more important when you have high latencies. And like I stated before, we had 70 millisecond latencies, which is huge. So we needed to increase the TCP windows to tweak them to be able to really decrease the number of sockets. So also, I decided to add some feature which did not exist in any client because we really thought we could do even better thing for our performance. And so the first thing for non-persistent bucket I added is the redundancy, which is a bit stupid because you just double every query, so you use twice more bandwidth, twice more memory, on the server, twice more CPU, so twice everything. But the thing is, if one server does not respond on a great query, then you don't care, because another server will respond to you. And this is very, very important when you have 50 requests to send to be able to respond to only one HTTP request, because there is always something that goes wrong on 50 requests. Always. So if you have 2 chances, then it really happens very less frequently. It's just a matter of probability. And also, I added, okay, so if the next server responds after that, the next request will just be dropped because we already responded to the query. So also, I added for persisted bucket the GetWith Replica. The thing is, on Couchbase, in the cap theorem, they want to partition things. They want to have the data very consistent, and so it's not made to be highly available. You have to deal with the non-high availability. So this is a bit sad because I know that my data are replicated on a persisted bucket, and I know there is one replica somewhere that could be stale. It could be stale, but if I know that one node is not responding for a few seconds, then what can I do? Then I detect that I have no more available sockets, and I mean I cannot reconnect, I'm disconnected, and this node looks dead for me. Okay, I just say I'm going to query the replica in that case, and until my node isn't available again, I will only query. So it's just for get. You cannot set on the replica. It's just for get. I will go to query the replica because here I prefer to have an inconsistent data than no data at all. Because, okay, I will probably lose a bit of money because I don't have the last updated profile, but it's okay. It's better than nothing. So now, let's speak about benchmark. Okay, if you attended to the previous presentation, my benchmark is not that good. But, and also, I tried something that we never even tried to do in production. So we have a data center in Paris and we have a data center in Tokyo. This is the worst case I find. We have 277 millisecond ping between both data center, which is really huge. Even when you hit on SSH, it's really a plague. And so I tried to use the old Couchbase driver. So since the 2.2, it's a bit different. I will talk a bit later. But everything is synchronous, like I said, and there is blocking call. So we have a cluster of 20 nodes. I used a cluster of 20 nodes in Tokyo, and I used my workstation in Paris. And so the cluster is 20 nodes, I said. I spawned 20 sockets per node. So this is something you can do using the API of the Couchbase client. And also, I did the while loop using 1,000 keys, which were present on the cluster, just to do gets. And so I spawned just 40 threads to do the while loop. So here we are just limited by the threads, the client threads, because all is blocking. And so it's simple math, 40 threads with a 277 millisecond ping, then it enables you to do roughly 150 queries per second. And it's really a huge amount of socket for a 8-core workstation. And also, it's really a huge number of sockets for my server. When I have 3,500 web server, then 20 sockets per node, it's really huge. And so, with my client, I was able, using only one socket per node, same cluster, same condition, extra, using only 4 client threads. So why didn't I put only one client thread? It's the same issue with the Moxie. It's because my client threads are doing all the hashing to locate where the keys are supposed to go. And so using 4 threads, I'm able to run more and more, 4 times more hashing. And this is the only purpose of this 4 client threads. And so I'm able, in the same condition, to hit roughly 120,000 get query per second. All the response are exactly the same, and this is it. So it really answers to all our issues of high latencies query and decrease of the number of sockets and threads, etc. And having the asynchronous API. So it was really cool for us. But the drawback is, what do we support? Because, yeah, we did it only for our own purpose, and so we just deal with the most common requests we are doing. So the get, set, update, add. Also, I implemented the get and touch because at some point I needed it. I implemented the increment and decrement because at some point I needed it. We are supporting the ketem allocator, which is the way to work with a non-persisted bucket. We also added the way to locate the keys in a Couchbase bucket, so persisted bucket. It was like 3 months ago. And so it permitted us to implement the GetWith Replica. Also, the last but not the least, it looks like very stupid to implement the stat query, but in fact, it was one of the worst commands to implement just because this command is very different from all the others. And it's just a command when you send one request and you have n response. And so in the asynchronous pattern I have, it's very difficult to deal with that kind of query. And also, we are supporting all the features you want to add because this project is open source and you can feel free to contribute, but you have to make sure that your specific use cases are the same as us because, yeah, like I said, it's not the official client. There is a lot of things we do not support. And so, if you have the same issue, then it could be your solution. And also, like I said, in Couchbase SDK 2.1 in .NET, they have implemented the asynchronous query in their client. But be careful, it's asynchronous query, so you will be able to spawn less threads, but it's still not pipelining anything. So here, if I do my benchmark again, which I didn't do, I'm sorry, I didn't have time for that. You will be only limited by the number of sockets and no more by the number of threads like we were before. So it's really a first huge step, and I'm looking forward for the pipelining. So this is it. Also, the second conclusion is that we are hiring at Criteo if you want to work in Paris or maybe in our office in Palo Alto. And yeah, that's it. Do you have any question? Yeah. We are starting to use it for one use case, but it was on the 2.2 and it's really buggy in the 2.2, so we stopped and did it again with our own driver, and we are going to migrate to the 3 point something to be able to use it again. But the problem of the XDCR is that it's usable only for persisted buckets. And we have still some buckets which are not persisted, and we still need to synchronize things between our data center. Also, the XDCR does not bring you the same low latency synchronization that we can do from the client. And since in some cases our clients are not stick to one data center, then we need to have this data really freshly synchronized. So it cannot work for every use case we have this synchronization. But yeah, good question, by the way. Yeah. Yeah. So the question is, how do I match the response and the query when I'm pipelining? So the thing is, in the Memcached protocol, you have a field in the header which is called the, I don't remember the name. Sorry? Oh, oh, opaque, yeah, opaque. The opaque field, which is exactly for this purpose. So you put a number in it, and in the response, you will have the same number. And so I match them with using this number. But in fact, Memcached always responds you in the same order on the socket than you are sending queries. So I'm just using a queue of all the query which have been sent, and they contains also the callback. And then when I receive a response, I just dequeue the last query, and I'm just matching this opaque field. And if something goes wrong, the opaque is not the same. And so I just break the socket, fail all the requests in the pipeline. And so it triggers the callback, sending there were an internal failure in the query. But in fact, it never happens. Okay, so the question is, do we suffer from the fact that we are pipelining and if there is a failure or the requests are dropped? No, because in fact we never have that kind of issues. We have a very good network, and Memcached anywhere is never failing. I never see that. So yeah, it could be from time to time one socket that fails, and so you just fail all the requests which were in queue. But okay, it can happen, but it's very unlikely. So, okay, so if you have no more questions, I think we're done. Thank you all.